Welcome to the Explainer. Today, we're cracking open the toolbox, the digital toolbox, that powers all of modern AI. We're going to look at the essential gear that teams use to take just raw data and turn it into, well, intelligent decisions.
So what does it really take to build AI? If you're imagining some lone genius in a dark room just typing out one single brilliant algorithm, well, you might be in for a surprise. It's actually way more like a massive construction project. You need this whole ecosystem of super specialized tools to even get started.
Yeah, let's stick with that idea for a minute. Think of an AI team setup as this incredible high-tech workshop. You've got your workbenches, your raw materials, super precise instruments, and even some heavy machinery. Every single tool has its own specific job, and the trick is they all have to work together perfectly to build something that can actually think.
Okay, so every project has to start somewhere, right? In AI, that means you've got to lay a really solid digital foundation. And this all starts with two absolutely fundamental choices. First, what language is your team going to speak? And second, what's the virtual workshop going to look like where you build the whole thing?
All right, first up, the programming language. And honestly, Python is the undisputed king of the hill here. Why? Well, it's simple, it's easy to read, and it has this massive ecosystem of libraries, like NumPy and Pandas, that do all the heavy lifting for you. I love how one source put it, Python lets engineers focus on thinking, not just getting bogged down in syntax. Of course, you've also got R. Think of R as the specialist tool, perfect for really deep statistical analysis. That's why you see it so much in academia and research.
Okay, language chosen. Next, you need your workshop, what developers call an IDE, which stands for Integrated Development Environment. It's basically where you write, test, and run all your code. And you've got options. There's the lightweight and super popular VS Code, or the really powerful Python-focused PyCharm. But when it comes to AI, there's one tool that really stands out from the pack.
And that tool is Jupyter Notebooks. So what's the big deal with Jupyter? Why is it so special? Well, it's this incredibly interactive environment where you can mix live, runnable code right next to visualizations and even just plain old text explanations, all in one document. This makes it absolutely perfect for trying out new ideas on the fly and then sharing your results with the rest of the team in a way that just makes sense.
So, we've got our language, we've got our workshop, but what are we actually building with? The answer, and this is the big one, is data. You have to think of data as the raw material. It's the fuel that powers every single AI model. Without data, you literally have nothing. And this brings us to probably the single most important rule in all of machine learning. Garbage in, garbage out. I mean it. You could have the most advanced, most brilliant algorithm in the world, but if you feed it junk data, you're going to get a junk model. It really is as simple as that.
So where does all this incredibly important data actually live? Well, for structured data, the neat stuff in rows and columns like a spreadsheet, that usually goes into what's called a relational database like PostgreSQL. But for all the messy unstructured data, things like images, videos, giant blocks of text, that stuff needs a much more flexible home. And that's where things like NoSQL databases or huge cloud storage systems like Amazon S3 come into play.
Now, for a lot of AI models, just having raw data isn't enough. You have to go a step further. In a process that we call supervised learning, you literally have to teach the model what it's looking at. This means a human being has to sit down and label the data, drawing little boxes around cars in a picture or reading a sentence and deciding if it's positive or negative. It is a massive amount of work, and it's all managed with specialized tools like Labelbox or CVAT.
All right, we've gathered our data, we've cleaned it up, we've labeled it. Now we get to the really exciting part, actually building the model's brain. This is where we break out the big guns, these powerful frameworks, to teach an algorithm how to find patterns all by itself in that data we so carefully prepared.
When you're talking about deep learning, there are really two giants in the room, TensorFlow and PyTorch. TensorFlow, that's the industrial powerhouse. It's built for deploying models at an absolutely massive scale. PyTorch, on the other hand, is really loved by researchers because it's so flexible and intuitive. There's this great quote from a developer who said that PyTorch just feels like you're writing normal Python, right up until the moment it starts predicting the future.
Here's something you have to understand. Building a model isn't a one-and-done kind of thing. Not at all. It's a process of constant, relentless experimentation. You might try hundreds, literally hundreds, of different variations of a single model. You tweak the parameters, you use different slices of the data. So the question is, how on earth do you keep track of all that without everything just turning into total chaos?
Well, the answer is you use dedicated experiment tracking tools. Think of platforms like MLflow or Weights and Biases as a super meticulous digital lab notebook for your entire AI team. They automatically log every single detail of every experiment you run, the exact version of the code, the model parameters you used, and, of course, how well it performed. This is crucial because it stops you from repeating mistakes, and it makes your work something that other people can actually reproduce.
Okay, so you've done it. You have an amazing model that works perfectly on your data scientist laptop. That's great, but turning that little prototype into a reliable, rock-solid product that thousands or even millions of people can use, whoa, that is a completely different ballgame. And that challenge, that discipline, has a name: MLOps.
This whole process usually follows a pretty standard pipeline. First, you lock down your code using something called Git. This lets you track every single change. Step 2, you package up your whole application into something called a Docker container. Think of it like a sealed box that ensures your code runs exactly the same way no matter where you put it. And finally, you use a beast of a tool called Kubernetes to manage and orchestrate all those containers, especially when you need to run them at a massive scale. But wait, the job isn't over just because the model is deployed. Not even close. Because the real world out there is constantly changing. And this leads to a really tricky problem. Why do these models that worked perfectly in the lab sometimes seem to go stale? You know, they just get worse and worse over time once they're out in the wild.
The answer has a name. It's a phenomenon called data drift. It's what happens when the new, real-world data being fed to your model starts to look totally different from the old data it was trained on. A classic example, right? A model trained to predict sales before the pandemic is probably going to fail spectacularly when customer behavior suddenly changes overnight. And that is why you have to be constantly monitoring your model with tools like Evidently AI. It's absolutely essential so you can catch this drift and know when it's time to retrain your model.
Wow. Okay, we've covered a lot of ground here. We've gone from programming languages and raw data all the way to these huge frameworks and deployment pipelines. So let's just take a breath, step back for a second, and see how all of these different tools fit together to form one single powerful AI toolchain.
You know, what's really fascinating when you look at it this way is where most of the effort goes. It's not actually building the model with those fancy frameworks. Nope. The biggest chunks are the data tools and the MLOps, basically all the plumbing and the logistics that make the whole operation work. And of course, underpinning all of this is the massive cloud infrastructure from the big players like AWS, Google Cloud, and Azure.
And really, that brings us to the most important takeaway of all. Great AI isn't just about a clever algorithm. It's not magic. It's built by disciplined teams who are using the right tools and the right processes for every single step of the journey.
The incredible thing is, this entire toolbox is changing all the time. It's constantly evolving. I mean, think about it. Just 5 years ago, a lot of these tools we've talked about didn't even exist yet. It really makes you wonder, right? What's the next big thing? What's the next tool that's going to come along and completely change the way we build AI?